Hey guys, as always, I hope you guys are having a good day. Today what we are going to do is conclude our chapter on polynomials. So go ahead and take out your notebooks and then follow along. Alright guys, in our final section of polynomials, we are going to apply it to some applications and we're going to focus on area, volume, and perimeter questions. So before we get into that, we want to just quickly review what all these terms mean. All right, so the first term that we want to make sure that we remember is perimeter. Remember, perimeter is going to be all the sides added up of your two-dimensional figure. In this case, let's say we kind of have this rectangular shape here. Remember that we are looking for what is this outside measurement around the entire shape. A couple of things that we saw on our homework that I want to just make sure that we're all okay with are these symbols. If you ever see these symbols, they just mean that any side that has the same symbol is going to be the same measurement. So remember, even if it's not labeled, because this one has this 2 lines here and this one has the 2 lines here, they're indicating that they both have a measurement of 5. So even if you don't see it, if it helps, you can write that in. So we have 2 measurements of 5. And then likewise here, this measurement is 4, and it's saying that is the same here, so this would be 4. So your perimeter of this then would be all the sides added together, so 5 plus 4 plus 5 plus 4. Or, again, you can say that it's 2 times 5 plus 2 times 4, whatever works best for you. What you'll end up getting here is going to be a perimeter of 18 units. The next thing we want to make sure we know is area. How we solve for area is going to differ based on the shape we have. But what you want to remember is that area is going to be how much space is taken up within that shape. So in the case of this rectangle, area is going to be length times width. And so it is going to be multiplying here versus adding. So in this case, you would take your 5 times 4. And then here we would get an area of 20 units. Then I'm going to remind you guys that area is going to be squared measurement because it is units times units, so squared. If you had a different shape like a triangle, it might be 1/2 base times height. Parallelogram would be base times height. So again, it just depends on the shape that you have, and you'd be given a formula for that. Volume is the space inside of a 3-dimensional figure versus a flat figure like we saw above here. Volume, again, is going to be how much space it's taking up inside here. And again, typically you'll get a formula for this. In terms of a rectangular prism, volume is going to be length times width times height. And so in this case, length typically being up and down, so 5. Width being left to right, so 4. And then width is just how wide a package may be or how wide a box might be, so 3. So in this case, you would do 5 times 4 times 3. So that would be 20 times 3, which in this case would be 60. No units, so I'm going to put units. And then the difference here is that volume is working with cubed units because we're multiplying 3 terms here. All right, so why that's important, though, is we're actually going to see this with some of our polynomials. So we just want to make sure we know which rules we're using. All right, so as a quick recap, we saw that perimeter, we know that we are adding here, so we're going to be adding our terms. Both area and volume, though, you're going to notice that you are going to be multiplying. All right, guys, so here is our first example. In this example, it says find the polynomial, and so you'll see right here this word polynomial. If you guys remember, that's just the expression that represents both the perimeter and then also the area. So we're actually going to be doing 2 different skill sets here. So let's go ahead and start with A, though. All right, so what we want to remember about perimeter, again, is that's all the sides added together. So we're going to take our 3x and add our 2x plus 5. And then again, please watch out here. Even though there's no measurement listed, there is still a measurement to the shape. And so we want to remember that it's going to be the same on both sides. So here it's 3x, so we can also say that it's 3x here. So we're going to add that to a part of our perimeter. And then likewise, even though the top is not labeled, it still has a measurement. In this case, it is 2x plus 5, so it's the same as the bottom. So we're going to add that to our perimeter. All right, and just like we saw before and we've been working on, what we're going to do next is we're going to go ahead and combine our similar terms or our like terms. So you can go ahead and add up all those x's. 3x plus 2x plus 3x plus 2x. That's going to give you a total of 10 x's. And then you would do the same with your numbers. You're going to go ahead and combine the numbers. We have a positive 5 and a positive 5, which is 10. And then you're going to put in that plus sign to show that it is adding. And so that final answer, that is your polynomial. This is the expression here that represents the perimeter of this shape. All right, so we're going to go ahead and find the area then here. And then if you guys remember, area is multiplying. In this case, we know that area is equal to length times width. So on our figure, length here is going to be 3x. And the width here is 2x plus 5. So 3x times 2x plus 5. And then what you'll notice here is it does become that distributive problem. So 3x times 2x. So remember, number times number here is 6. Letter times letter is x times x is x squared. And then same thing now. 3x times 5 is going to be 15. It's positive, so keep the plus sign there. And then you're also going to keep the x here. All right, and then this answer again is the polynomial that now represents the area, the length times the width. And so that's what you guys are going to be doing in this section. So you're going to take your knowledge of perimeter and area, and then you're also going to involve and combine that with your knowledge, though, of polynomials and multiplying and adding and combining our like terms. All right, guys, so here are your two examples for you to try. One is a perimeter question, and then one is an area question. All right, I'll fast forward through this so you can see the steps, but then also so you can check your answer. All right, guys, let's go ahead and talk about these answers. So for perimeter here, remember you're combining all of your sides. I'm going to tell you guys to watch out for, again, the negatives though, because this is a -1 plus -3, which is -4. And then you're adding some positive numbers here. So I end up getting a -1 though. So this answer here, or this polynomial, is what is representing my perimeter here. For area, remember it's the area inside of this shape. You are multiplying your two terms here, and in this case, they're binomials. Just as a quick reminder, I set up the table for those of you who do like the table method. You can use that here. Or those of you who are using double distributive, that works as well. Final answer here is the polynomial 4x squared plus 4x minus 8. And again, that is the polynomial that is going to be representing your area. All right, so hopefully that makes sense. Let me know if it does not. But again, this lesson is combining our knowledge of multiplying and adding polynomials with the skill then of finding area, volume, or perimeter of a shape. All right, guys, that concludes our chapter on polynomials. Tune in next week for our final episode. We will cover transformations, and that's going to take us to the end of our year. So hope you guys have a good weekend, and I will see you guys next week. Bye, guys.